Cool. I'm going to go ahead and get started and talk a bit about Hyperaware, which is a spatial governance protocol for connected devices. So I'm going to talk about a couple of things. We'll start out with the problem that we were trying to solve as we started to develop this, and then the opportunity, and then we'll go back to the problem, a bit about Hyperaware, especially around zones, devices, and enclaves, and then we'll talk about the future. So just to dive straight in, the problem starts with that it's very difficult to trustlessly keep track of where things are. Ships are sailing around the world all the time, in and out of ports, in between sovereign jurisdictions, exclusive economic zones, crossing invisible borders. Cars are moving around the world all the time, again, moving through countries, through different jurisdictions within a country, whether it's a city or a county or a congestion zone. People are also moving and carrying their devices along with them. Drones are coming online, and they're also moving from place to place. And I guess this is just a point to mention this notion of governance and the idea that, well, for since society evolved, we have had sets of rules that govern physical places on Earth. And when we move from place to place, we sort of adopt or accept that we're coming into a new area that has a new set of rules. So when we cross a country border, we implicitly know that by entering that country, we are abiding by laws that govern that country. But this is a pretty fuzzy and pretty difficult to enforce system of governance. Really, someone has to see you breaking the law and then prosecute you in order to actually have the laws enforced. So Hyperaware is really looking at how we can automatically and reliably govern ourselves and especially our devices based on where they are. So currently, these vehicles, these devices, they might self-report their locations and say where they are. A lot of times they don't report their locations. You could say that in a way, a car is reporting its location by having a license plate, and cameras can take a picture of the license plate and work out where they are. But there's not really any sort of active digital reporting mechanism for personal vehicles, to my knowledge, now in most of the world. And if nothing else, it's easy to view. We developed Hyperaware kind of with the initial use case of looking at the London congestion zone, which is an optical character recognition system where they take photos of your license plate. And if you want to evade the London congestion zone charges, you can just take off your license plate or put a black paint on it. Now, obviously that's illegal and you might get fined a very large fine, but it is easy to evade. So as complexity grows and the precision of where things are matters more and more, so does the difficulty of trustlessly keeping track of it all. And I'll just leave this image here for a second just to kind of emphasize how complex our world is getting. And we'll come back to this in a minute. So let's drop out of the problem for a second and talk about the opportunity. First off, obviously our world is more connected than ever. This is due to the maturation or evolution of the noosphere, which is a concept that was put forward by a priest philosopher named Teilhard de Chardin. He was working kind of around the turn of the 19th into the 20th century, and he talked about this idea that you have the sort of litho or geosphere, which is the physical matter of the earth. Then you have the biosphere, which is the sort of part of the earth that has life in it. And then the noosphere is what's emerging out of the biosphere, and that's kind of the envelope of meaning that wraps around the world. And kind of started out very simple, very unevolved, and as consciousness has gotten deeper and deeper, this noosphere has evolved, and with it, the sort of transfer of meaning between individuals in the noosphere. I kind of think of that as the same thing, the evolution of the noosphere and the evolution of our ability to communicate in more sophisticated ways. And pretty recently, a new sort of sentient entity has joined the noosphere, which are machines, connected devices that are capable of communicating with each other, of processing information, storing information, transmitting information, perceiving their environment, and responding. So as we've evolved, we've developed things like TCP/IP protocols, Wi-Fi and cellular networks, 5G networks. This is obviously all starting to go more up than over at this point. And as I just mentioned, we've developed these connected sensors. And I want to take a moment to define what a connected sensor is, and talk a little bit about them because it's pretty fundamental to the idea here. So connected sensors are digital devices that have sensory or apparatuses or almost like organs attached to them. They can record environmental information. They can process, store, and transmit digital data to other sensors. They can measure time, which is a really, really important piece, because since the speed of light is constant, with the fact that they can measure time, they can locate themselves by triangulating their position in relation to other devices that have also hyper-accurate clocks. So the GPS systems, the network of a couple of dozen satellites that are orbiting the Earth with atomic clocks on board, and they send signals to receivers, which are kind of installed on these connected sensors. And with the information that they receive from these GPS satellites, connected sensors are able to calculate their position down to a couple of meters accuracy on the Earth's surface or in space. And yeah, we'll talk a bit about that a little bit later on. And now they also can control digital identities. And this is a really, really important point, and a point that deserves a bit of explanation. So what was a machine's identity before this sort of new Web3 world came about? Really, in the Web 2.0, it was an IMEI number, an RFID chip, universally unique identifier. So some kind of number or random string that would let that device differentiate itself from other ones. But now in Web3, obviously, we all know that our identities on the internet in the Web3 world are really fundamentally controlled by a private key. And you have your public identity, which is the linked public key, and then the private key, which in a self-sovereign world never leaves the devices that is in your control. So how can a machine have an identity that it controls in the Web3 world? We're going to do a little aside here and talk a bit about enclave computing. So, and I should issue a bit of a disclaimer. I am not a specialist in this. I've done a fair bit of research in understanding this, but I am not a computer scientist or a computer security engineer. So if I say something that doesn't quite check out, bear with me. And if you're listening now and I say something that doesn't quite check out and you want to weigh in, please feel free. So within a computer, there is an area which is called the execution environment, which is sort of, it may sound a little weird, but I kind of think of it as the mind of the computer. So it's where the computer is able to hold and process information as it's going about its day. So at the end of the day, it's pretty basic. It can bring digital information, binary information in, and it can analyze it or operate on it and then send it out. That's the input-output part of a computer. On a secure enclave or in enclave computing, there are two parts to this execution environment. There's the host, which is represented by this lighter box, and then there's the enclave, which is represented by the black box. And it's represented by a black box for a reason. The host is an untrusted execution environment that developers have access to and are able to see the data that is being analyzed within that. Whereas inside of an enclave, there is a private key and there is the capability for secure computations to happen. And what's really important is that the people that have access to this host are not physically capable of looking inside the enclave to see the state of the computations that are happening. So within this enclave, algorithms can run, so code can run, which means that signatures, digital signatures, can be created with the private key. And on top of that, because any sort of algorithms can run, computations can happen on data. And the reason that we've got this term secure multi-party computation is because whoever is sending data in to be analyzed, well, they can encrypt it with the enclave's public key that corresponds to its private key, so that only the enclave can decrypt that information. This is a really, really interesting new field of research that's coming about, that I think the implications of enclave are going to be pretty huge. For example, one that I've heard of is insurance companies all comparing their policyholders lists to make sure that people don't have multiple policies taken out with the same on the same asset with multiple companies, because that's insurance fraud. Well, obviously, insurance companies aren't willing to share details of their policyholders with their competitors. That's really proprietary and strategic information. But if they all analyze this information inside of a secure enclave, they can detect the wrongdoers without actually revealing any strategic information to their competitors. So in an enclave, humans can program the algorithms executed. They can be sure that the algorithms haven't been tampered with, that the algorithms run correctly, and they can be granted access to computed values, so the algorithms can return data. But they can't access the machine's private keys, and they can't see the secrets that are revealed in the enclave. So this key point, that they can't access the machine's private keys, is really pretty fundamental to the notion of these machine identities in the Web3 world that we were talking about a little bit earlier. So with an enclave, with a secure enclave, machines can functionally have identities. And since we obviously know that funds on a blockchain are controlled by private keys, that means that they can own money on a blockchain that only can be spent when a valid digital signature is created with that private key, which can only really happen inside of an enclave. And since algorithms run correctly, there's a whole world of opportunity that opens up with enclave computing when you connect these enclaves to blockchains. So back to the problem, it matters where things are. And just to talk a little bit about this, coming back a little bit to that idea of when we move from place to place, our objects, our physical bodies, become subject to new laws as we move into a new country, or as we move from city to city and county to county and into private property and out of private property. Different rules apply to objects based on their position in space. And I've got a few maps here. I love maps. This is why I made Hyperaware, because I get to work with maps. Why I built it with the team that I'm working with. So here's obviously a map of the country borders, but these zones, the idea that you have different rules depending on where you are, might be here. These represent areas that have access to a certain internet provider. These are parliamentary constituencies of London. So who you're allowed to vote for and who represents you in government. Here are a couple of different property boundaries in an area of London. These are exclusive economic zones. The blue areas here, these are who has the economic right to the resources that are harvested from these areas. This is an area called the IRTC, the transit corridor through the Gulf of Aden. This is one of the busiest shipping lanes in the world, and they have a very strict scheme to make sure that traffic flows smoothly, and which directions where and how you cross this area and so forth. You might have rules about what happens at different depths of the ocean. You have rules about what happens in different areas of the ocean. Who are the authorities that you contact if you get into trouble? These are nav areas. These are who's responsible for issuing the navigational warnings for those parts of the ocean. You have rules about what types of aircraft are allowed to fly at what heights and where. And we'll talk about this in a minute. This is, I think this is air traffic zones in the UK. So different rules apply to objects based on position in space. And further to that, it also depends on the nature of the object. A human walking into one place, the rules depend on the characteristics of that human. And a shipping container coming into a port, it depends on what's in the shipping container, maybe who owns it. So there's this whole really complex set of rules that govern things based on where they are, but a lot of this complexity is really lost, or at least maybe not lost, but it's not reliably and efficiently enforced. So coming back to this, a hugely complex idea of the international shipping and logistics system. What if you have in this kind of huge pile of shipping containers, you might have one container that has an illicit substance in it, like some drugs. Another one might have guns in it, and I don't know, let's say this one's carrying some humans. How can you detect and make sure that the shipping containers that are coming into a port are complying with the laws that the government that controls that port has put into place about what is allowed to be imported and so forth? So our challenge was to keep track of things, and this is again why we built Hyperaware. Keep track of things, apply the right policy based on an object's characteristics and location. And we wanted the users to be self-sovereign. And what this meant in our interpretation was that they control their identity, that they have the right to register an area or register a device, what information they provide with that device, what policies are governed in that area. And then they also have the right to choose whether or not they want the data that they control, their identity, their information, their personal information, if they want that to be private. And all of this obviously is built on as many decentralized and privacy preserving technologies as appropriate. So it's all Web3. So Hyperaware is a spatial governance protocol for connected devices. We launched the application a few weeks ago and recently pitched at the Future of Blockchain competition on this past Monday. And when I say we, I'm talking about the team that I've been working with from London Blockchain Labs. The Hyperaware protocol has a couple of components. It has a spatial zone registry, it has a device registry, and it has a private locations analytics engine where we analyze the positions of the devices that are registered and check to see if they are inside any of the policy zones we have registered on the system. So I'm going to do a bit of a live demo in a sec, but in the zone registry, authorities, whether those are governments or firms or really anything, and I think this is an important point, that we designed the Hyperaware protocol to make no assumptions about the users. We set it up so they could adopt it and govern devices based on where they are without making any judgments about what they are. So this might be the Transport for London or Greater London Authority. It could be Amazon that wants to register the area around a warehouse zone. They register zone geometries and the policies they want enforced inside that zone on Hyperware, and they store a DID document on Arweave, which is a sort of decentralized data storage platform. They registered the DID on Ethereum, and we are developing the ability to register private zones. So let's just quickly look at the zone registry, which is right here. They have the option to put in the name of the zone. They would upload a file that it is a GeoJSON file that has a polygon representing the geometry. And then you put in information about who will get paid when a vehicle enters and how much they'll get paid. And then you add it to the zone. And when you register this deploys that did document onto Arweave and registers that endpoint on Ethereum, on an Ethereum registry. And I guess, yeah, just to kind of quickly show you why I'm talking about all of this, this is Hyperaware demo, where advance represents vehicles or devices moving around Europe. And as they travel into these policy zones, it's detected and the appropriate policies are enforced. And then when they move out of a policy zone, say here, a smart contract method is invoked. So just conscious of the fact that we're coming up, we got about 5 minutes left. The benefits of the zone registry is that users are self-sovereign. They control all of the information that is about the policy zones. So that's both the geometries of the zone, but also the policies that are enforced inside of them. It's opt-in, and I think this is an area that needs a bit more research, but devices will need to, there needs to be some way to distinguish which devices are subject to the rules of that zone. For example, if you have a congestion zone where cars need to pay a certain amount, you might not want that to apply to airplanes, for example. It needs to be efficient and it needs to leave room for market forces. And this is where I want to talk a little bit about this, the idea of the zone registry and why I think it's a pretty interesting idea, and that's to use DJI as a case study. So DJI, the world's biggest drone manufacturer, they have this no-fly geozone map where DJI drones are not allowed to fly because it's an area around a military base or around maybe an airport. You can see here they're not allowed to fly over 150 meters. Here they're not allowed to fly at all. This is great, but the trouble is DJI went ahead and coordinated with all of the governments that they are selling that are kind of signed up to this scheme, and got a hold of all of the spatial data of where those zones are. So you have DJI down here connecting with a bunch of governments. That's well and good, but what about a bunch of other market players come in? Let's say you're a startup, you want to start making drones. Well, it's not really tenable for you to connect with the civil aviation authorities of all of the countries that want to you want to sell your drones in, and get access to the data, get it into your system, do it all appropriately. You can imagine that the complexity explodes when you have multiple market players and multiple government authorities. One government, let's say they want to update a zone and change the boundaries of the no-fly zone. It just won't work. So with this spatial data registry, which we called GeoLocker for an ETH London hackathon. GeoLocker is a layer of smart contracts that serve as a bridge between governments and market players. And when governments want to push an update, they push it into the smart contract, and market players are all looking at these smart contracts to get the most up-to-date spatial data. They can kind of pull that automatically. It's a really much more efficient way to still leave room for the market to compete, but also efficiently coordinate on getting the most up-to-date spatial data. But like I say, there's lots of research to be done here. So the device registry, device owners register an identity and write a DID document on Arweave, and then they register that DID on IoTeX blockchains, and they do have the option to have private device data. And you can see here, when you register the DID, you can flip this tab, is private vehicle, and we simulate what that means here by you know, here's an example of a vehicle that is private. So we have privacy mode off here. Only once it is detected inside of a zone does privacy is the privacy revoked. Moving along to our private locations analytics engine. Again, this is leveraging that enclave computing technology where you can perform secure multi-party analytics algorithms inside of the trusted enclave and not reveal the plain text of the data that was sent in to anyone, including whoever's controlling the network. So we use Intel SGX. We fetch spatial data from the decentralized registry, and as points locations stream in from the devices that are registered, we test to see which zone they're in, and then if they're inside, we take action. This could mean invoking a smart contract that that zone owner had registered to. Could also mean re-encrypting data from the device and alerting someone, say, as a ship enters a port, we could re-encrypt the cargo manifest and transmit it to the port authorities. And this really opens up a really wide world where zone owners can specify any smart contracts they want and any input parameters that they're going to require. Again, we really didn't want to make assumptions about how that would work. This is a point of centralization, I'll just say, and we've been thinking about how to address that by maybe making a permission network of validator enclaves run by the government participants that has multi-signature slashing contracts. We've also thought about using the Oasis Labs privacy preserving smart contracts. Haven't looked too closely into that, so lots of research to be done. Briefly on the team, my name's John. I'm technical director at London Blockchain Labs, and I was working with an amazing team of developers. Jason James was our lead. He's just finishing up his MSc in computer science at UCL. And then Leo and Tony are also really, were strong engineers for us, developing smart contracts, back end, front end. So what's next? A globally coordinated network of connected sensors, a privacy preserving surveillance apparatus built by and for us that uses enclave computing. Maybe eventually, for now, more research, more validation, more prototyping. And that's just to say, anybody listening to this, please feel free to get in contact with me and tear this apart. Tell me why you think it's dumb. Tell me why you think it might work. Share it with anyone who you think might be interested in it. We're really, really keen to get eyes on this and start to push it forward. And really that is why I wanted to talk about this today, was to share it out with the world and start to get some feedback. So you can see our demo on hyperaware.io. You can email us at trust@hyperaware.io. We're on GitHub at We Are Hyperaware. We've got our repository open source. It's pretty messy at this point. We've still got a lot of work to do. We were just in sprint mode to finish for this hackathon. And then you can tweet at me at JohnX25BD. I'm going to go ahead and, you know, we've got maybe a minute or two for questions if anybody wants to ask any questions. Great. All right. Well, yeah, feel free to reach out and I will hand it off to whoever is next.